In this example, we have a motorcycle that's traveling in a straight line. The motorcycle starts from rest and moves with the acceleration profile shown, where the motorcycle is brought to rest in 25 seconds. We want to draw the velocity profile and determine the motorcycle's total distance traveled. So here we have the acceleration curve. So the motorcycle starts from rest, it accelerates for 7 seconds, then increases its acceleration for 8 more seconds, then has 0 acceleration, then starts to decelerate until it finally comes to rest again. All right, so what do we know? Well, we know that the motorcycle starts and ends at rest, and we want to find the velocity profile and the total distance traveled. All right, so let's get familiar with the problem. So what we're going to do first is divide the acceleration graph into sections, because this is obviously an erratic motion problem. And within each section, the motion is continuous. So we'll do that. Then after we do that, we can use the graphical method and the knowledge that we have of the acceleration curve to draw the velocity time curve. Once we have that, we can solve for unknowns. So for example, we don't know what t3 is. That's this time right here. So the time between the positive acceleration and the negative acceleration. We don't know that time, so we're going to use the graphical method to determine that. And then we'll also use the graphical method to determine the displacement. All right, so here is the velocity curve. We can draw this without knowing things. We know the shape, right? So we've divided the acceleration into its regions. So it has 4 regions. And the velocity is also going to have 4 regions. Now, whenever the acceleration is a flat line and constant, that means the velocity increases at a constant rate, which means that it's a straight line. So it'll go for a straight line until time t1, and the slope of that line is the acceleration. So segment B, or region B, has a higher acceleration, so it's going to have a higher slope. And then 0, right? There's 0 acceleration here, so the velocity is constant. And then we have a negative slope until we go back down to 0. So the acceleration time curve gives us sometimes, right, t1, t2, we don't know t3, and we know t4. So we can use that information and the fact that it starts and ends at rest to determine this unknown time. All right, in the graphical method, we need to remember that the change in velocity is equal to the area under the curve. So if the motorcycle starts and ends at rest, we can use that to determine the unknown time. So the change in velocity from point 4 to the initial position is 0 because it starts and ends at rest, and that's the whole motion, right? So that means the area under all these segments has to add up to 0 because there's no change in velocity. So area 1 plus area A plus area B plus area C plus area D has to equal 0. And the area is very easy. It's a rectangle, right? So height times length, and so on. And don't forget that the negative one will have a negative area. So you can see that right here. And that also includes the unknown time t3. So t3 is the only unknown, so we can solve for that, and we see that it's about 17 seconds. All right, next, we can use that same fact that the area under the curve is equal to the change in velocity to determine these unknown velocities v1 and v2. So v1 minus v0 is the area under A right here. So we do that and we find that the velocity at 1 is 10.5. And then the change in velocity between 2 and 1 is the area under B. So we can use that to find the velocity at 2, which is 34.5. All right, the final step, will be to determine the distance traveled. So now we're going from velocity to position. So the displacement is equal, or the change in position is equal to the area under the VT curve. So again, if we do the total displacement from forward to the initial, that's going to equal all the areas. So these areas are the area under the velocity curve. So all of these areas. So here you can see the equation for that. We have some triangles. That's why you see the 1/2. So this is just 1/2 height times base. Here I divided it into two areas. So this triangle and this rectangle, and added those two together. So you get all the areas, and you find that the total distance traveled is around 429 meters.